Download this code from codegive.com, link in the description below. OK, let's dive into data binding in C++ with Visual Studio, covering various aspects from basic concepts to practical implementation. This will be a detailed tutorial with explanations and code examples. Understanding data binding, bridging the gap between data and UI. Data binding is a powerful technique that allows you to establish a direct connection between the data in your application, the model, and the user interface elements, the view. When the data changes, the UI automatically updates to reflect those changes, and vice versa. This simplifies UI development, reduces boilerplate code, and improves maintainability. Why use data binding? Reduced boilerplate. You don't need to manually write code to copy data between your data structures and UI controls. Improved maintainability. Changes in data are automatically reflected in the UI, reducing the risk of inconsistencies and making it easier to update the application's behavior. Clean code. Data binding separates the UI from the underlying data logic, leading to cleaner and more organized code. Faster development. Data binding can significantly speed up UI development by automating many tasks. Data binding in Visual Studio C++, Windows Forms or WPF. Data binding in C++ with Visual Studio primarily applies to two main UI frameworks. One, Windows Forms *, a legacy framework, but still widely used. Data binding is supported but can be a bit more manual. 2, WPF, Windows Presentation Foundation, a modern framework designed with data binding as a core feature. WPF provides a richer and more flexible data binding system than Windows Forms. We'll focus primarily on WPF due to its superior data binding capabilities. However, I'll provide a brief example using Windows Forms for comparison. WPF data binding concepts. Before we dive into code, let's review some key WPF data binding concepts. Source. The object providing the data. This is typically a class that exposes properties. Target. The UI element, example text box, label, combo box, that displays or updates the data. Binding. The link between the source and the target. It specifies which property of the source is bound to which property of the target. Binding mode. One-way. Changes in the source update the target. Two-way. Changes in either the source or the target update the other. One time. The target is updated only once when the binding is created. Useful for initial values. One way to source. Changes in the target update the source. Less common. Two way to source. Same as two way. Update source trigger. Determines when changes in the target property are propagated back to the source. Common values include property changed. Updates the source whenever the target property changes. Lost focus. Updates the source when the target loses focus. Suitable for text boxes. Explicit. Requires manual intervention to update the source, using binding expression. Update source. Converters. Allow you to transform data between the source and the target. For example, you might use a converter to format a date, convert a value to uppercase, or display an image based on a Boolean value. Data context. The default source for data bindings within a particular UI element or its children. You can set the data context property of a window, panel, or control to specify the object that should be used as the source for bindings within that element. I notify property changed. An interface that source objects should implement to notify the UI when their properties have changed. This is essential for WPF to automatically update the UI when the data changes. WPF data binding example, a simple person class. Let's create a simple WPF application that displays information about a person. 1. Create a new WPF project ***. In Visual Studio, create a new project and choose the WPF app.NET Framework, or WPF app.NET template, depending on your .NET version. 2. Define the person class ***. Create a person class that represents the data we want to display. Crucially, implement iNotify property change to enable data binding updates. Explanation ***. iNotify property changed ***. This interface is essential for WPF data binding to work correctly. It defines a single event, property changed. Property changed event handler and property changed event args***. These are part of the .NET Framework infrastructure for handling property change notifications. We declare the delegate and event. On property changed ***. This protected virtual method is responsible for raising the property changed event. It's called whenever a property's value changes. It takes the name of the property that changed as a parameter. Properties, first name, last name, age. These are the properties that we want to bind to UI elements. The set accessor of each property raises the property changed event, informing the UI that the property's value has been updated. *msclr/event.h** needed to use the event keyword. System and system component model * necessary for the iNotify property changed interface. GNU * allocates managed memory. 3. Design the WPF window, XAML. Open main window.xaml in the Visual Studio Designer and add the following XAML. Explanation ***. XMLNS local ***. This XML namespace declaration maps to your project's namespace. Replace WPF app1 with your actual namespace if it's different. This allows you to reference your person class in XAML. Binding path * specifies the property of the source object to bind to. For example, path equals first name binds the text property of the text box to the first name property of the data source. Mode equals two-way * indicates that changes in the text box should update the person object, and changes in the person object should update the text box. Update source trigger equals property changed * specifies that the source property should be updated whenever the text property of the text box changes. Xname equals output text block * allows us to access the text block in the code behind, C++. Button click equals button _ click * this sets up the button click event handler. 4. Code behind, main window.xaml.cpp. Now, add the code behind logic to set the data context of the window to an instance of the person class. Also, add code for the button click event. Explanation ***. This dash data context equals person, * this line sets the data context of the main window to the person object. This means that all data bindings within the window will use this person object as their source, unless otherwise specified. Safe _ cast person caret, this dash data context, * retrieves the current data context and casts it to the person type. The safe _ cast is used here to ensure that the cast is safe and throws an exception if the data context is not of the expected type. Output text block dash text equals, * updates the text block with the current values from the person object. How to run the application *. 1. Build the solution in Visual Studio, build solution. 2. Run the application, debug-start without debugging or debug-start debugging. You should see a window with 3 text boxes. The text boxes will be pre-filled with the initial values of the first name, last name, and age properties of the person object. If you change the values in the text boxes and click the Update Person button, the text block below will display the updated information, demonstrating that the data binding is working in both directions, two-way binding. Key improvements and considerations. Error handling. In a real-world application, you'd want to add error handling to validate the data entered by the user. For example, you might want to ensure that the age is a valid number. You can use WPF's validation features or write custom validation logic. Data conversion. The example uses simple string and integer values. If you need to work with more complex data types, example dates, currencies, you'll need to use data converters to transform the data between the source and the target. Collections. For displaying collections of data, example a list of people, you can use WPF controls like listbox, data grid, and list view along with an observable collection to automatically update the UI when items are added or removed from the collection. Commands. WPF commands provide a way to encapsulate actions and decouple the UI from the underlying logic. Commands are often used in conjunction with data binding to enable UI elements to trigger actions in response to user input. MVVM, Model View Model. For larger and more complex applications, it's highly recommended to use the MVVM pattern. MVVM separates the UI, view, from the business logic, model, and introduces a view model as an intermediary. The view model exposes properties and commands that the view can bind to, making the application more testable, maintainable, and scalable. Windows Forms example, brief. Data binding in Windows Forms is less declarative than WPF. You typically use the binding class to create bindings in code. Key differences from WPF data binding. Code-based Windows Forms data binding is typically done in code, C++, whereas WPF uses XAML for declarative binding. Data source update mode. Controls when changes in the UI are propagated back to the data source. No automatic property change notification. In Windows Forms, you'll often need to manually update the UI when data changes, even when using data binding, especially for custom objects. This is why iNotify property changed becomes more important for complex scenarios. Conclusion. Data binding is a powerful technique for building more maintainable and efficient UI applications. WPF offers a robust and flexible data binding system, while Windows Forms provides a more basic implementation. For larger projects, using the MVVM pattern in conjunction with WPF data binding is highly recommended. This provides structure and testability. Remember to handle errors, use data converters when necessary, and implement iNotify property changed in your data classes to ensure that the UI is updated automatically when the data changes. By understanding the concepts and practicing with examples, you'll be able to leverage data binding to build compelling and maintainable C++ UI applications.